This is Note Taking Guide 4.7 for Math 1. So we're going to talk about growth and decay today. Also, it can be called appreciation and depreciation. Really what it is, though, is just when something's going to grow in value or something's going to lose its value. If we're talking about money, or if we're talking about something like if we're talking about germs or bacteria growing or dying, those kinds of things happen. There's one general formula for it. Sometimes we change the letters around, and we'll use two generalizations of that formula today. But we always start with the amount that we think something is worth, or we're investing, or whatever kind of thing. And then it's 1 minus b. B is the rate of decrease. In just a minute on the next one, it will be a rate of increase if it's positive, if we're expecting it to grow. And then this power right here, that variable of t, is time. If we substitute our information into those formulas, we're going to be able to find amount of decrease. This is the decay formula because of the minus sign right there. But if we put a plus sign right there, then it's actually would be the increase or appreciation or growth formula. So this example down here says a popular medicine loses 23% of its effectiveness each hour. Find how much of the 200 milligrams of each pill is working after 5 hours. So they took the initial value, put it in. It was 1 minus the decimal point number of the percent. So they changed that percent to a decimal point number, and then just solved that equation after they put in t for time. It's quite simple to do, so let's see if we can figure it out ourselves. So let's write down our formula so we know what we're substituting stuff into here. We have y equals a times 1 minus b times raised to the t power. So it says you've just purchased a car for $16,000, and we were told that it would depreciate in value by 15% each year. Write an equation, describe this depreciation, then find the value of the car after 6 years. So we know the value of the car was $16,000, so it gets to be put in for the A. 1 minus the depreciation amount, but as the decimal point number, so 15% gets written as 0.15, and then it would be for the number of years or time. So we're going to actually substitute in right here for time. We're going to put the number of years we have. So we're going to substitute 6 in right there, and then we're just going to put this through our calculator. So 1 minus 0.15 to this power of 6 for 6 years. So let's just sub that into our calculator of 16,000, and then times it by 1 minus 0.15 and raise that to the 6th power. When we do that, we get 6,034.39. So that number actually is the value of the car after it depreciates for 6 years. In a similar fashion, growth works the same way. If you notice, it's still the initial value. You still have the rate of increase or decrease, and you still have the period of time. The only thing that changed there is plus. So I really think of them as the same formula. I just know that when I'm going to grow, it's going to be a plus sign there. When I'm going to get smaller, it's going to be a minus sign there. So say you purchase a coin at a coin store for $27, and it's supposed to appreciate in value of 4% each year. What's the value after 10 years? So again, we're just subbing into that formula. So y equals 27 times 1 plus the interest rate this time, which is 4%, which is 0.04 as a decimal point number, and then raised to time, which is 10 years. So plug that in your calculators. 27, open your parentheses, 1 plus 0.04, close your parentheses, raise it to the 10th power, and just hit enter. Your calculator will do that work for you. You get 39.97 if we round. So our coin is worth $39.97 after having it for 10 years. So really today you're just substituting numbers into those growth and decay formulas. It shouldn't be too hard. Good luck with this today. Thanks, guys.